Good day everyone. For today, we will be learning some chemistry concepts. We will tackle about solubility, solubility product constant, and common ion effect. Solubility is the chemical property referring to the ability of a given substance, a solute, to dissolve in a solvent. Let us first define these terms. The substance which is dissolved is called a solute. It can be of solid, liquid, or gaseous, while the substance in which the solute is dissolved is called a solvent. Solubility is measured in terms of the maximum amount of solute dissolved in a solvent at equilibrium. The resulting solution is called a saturated solution. This saturated solution is a chemical solution containing the maximum concentration of a solute dissolved in the solvent. The additional solute will not dissolve in a saturated solution, forming the precipitate. The amount of solute that can be dissolved in a solvent to form a saturated solution depends on a variety of factors.
Temperature. Solubility increases with temperature. For example, you can dissolve much more salt in hot water than in cold water. Pressure. Increasing pressure can force more solute into solution. This is commonly used to dissolve gases into liquids. Chemical composition. The nature of the solute and solvent, and the presence of other chemicals in a solution affects solubility. For example, you can dissolve much more sugar in water than salt in water. Ethanol and water are completely soluble in each other. Certain substances are soluble in all proportions with a given solvent, such as ethanol in water. This property is known as miscibility. The term miscibility refers to the ability of a liquid solute to dissolve in a liquid solvent. Solubility is a more general term, but it is more often used to mean the ability of a solid solute to dissolve in a liquid solvent. Miscibility is used when talking about the solubility of, specifically, liquid solutes. Miscible liquids are also defined as liquids that can mix to form a homogeneous solution. They generally mix without limit, meaning they are soluble at all amounts. For liquids, the distinction is easy. Miscible is anything that blends together, such as alcohol and water. There is no clear separation. Immiscible example is oil and water. No matter what you do, there will be a visible separation. Solubility is measured in number of moles per 1 liter of the solution. Solubility indicates the maximum amount of a substance that can be dissolved in a solvent at a given temperature. Such a solution is called saturated. Calculate the molar mass of the dissolved compound as the sum of mass of all atoms in the molecule. Atomic weights of corresponding elements are given in the periodic table of the chemical elements. Divide the mass of the dissolved compound by its molar mass to calculate the number of moles. Divide the number of moles by the solution volume in liters to calculate solubility in mole per liter.
The solubility product constant is the equilibrium constant for a solid substance dissolving in an aqueous solution.
It represents the level at which a solute dissolves in solution. The more soluble a substance is, the higher the Ksp value it has. Consider this general dissolution reaction. To solve for the Ksp, it is necessary to take the molarities or concentrations of the products and multiply them. If there are coefficients in front of any of the products, it is necessary to raise the product to that coefficient power, and also multiply the concentration by that coefficient. Note that the reactant, AA, is not included in the KSP equation. Solids are not included when calculating equilibrium constant expressions, because their concentrations do not change the expression. Any change in their concentrations are insignificant. KSP represents the maximum extent that a solid that can dissolve in solution. Calculate the solubility product constant for lead chloride. If 50 milliliters of a saturated solution of lead chloride was found to contain 0.2207 grams of lead chloride dissolved in it. First, write the equation for the dissolving of lead chloride, and the equilibrium expression for the dissolving process. Second, convert the amount of dissolved lead chloride into moles per liter. Now, create your ice table. Fourth, substitute the equilibrium concentrations into the equilibrium expression and solve for KSP. Estimate the solubility of silver chromate in pure water if the solubility product constant for silver chromate is 1.1 times 10 raised to negative 12. First step is to write the equation and the equilibrium expression for silver chromate. Create an ice table wherein I stands for the initial concentration, C for the change in concentration, and E for the equilibrium. Substitute the equilibrium amounts and the KSP into the equilibrium expression and solve for X. X is the number of moles of silver chromate that dissolves in every liter of solution. At equilibrium, the concentration for silver is 2x raised to its coefficient's power, and the concentration of chromate is X. Substituting the KSP value, we get 6.5 times 10 raised to negative 5 for the value of X. When two electrolytic solutions are combined, a precipitate may or may not form. In order to determine, one must examine two factors. Determine the possible combinations of ions that could result when there is a dilution of all species present and must be taken into account. Determine if a precipitate of lead chromate will form. First, determine the overall and the net ionic equations for the reaction that occurs when the two solutions are mixed. Using the dilution equation, C1V1 equals C2V2, determine initial concentration of each species once mixed, before any reaction takes place. Using the initial concentrations, calculate the reaction quotient Q, and compare to the value of the equilibrium constant, KSP. Q is greater than the value KSP, so a precipitate of lead chromate will form. The solubility of an ionic compound decreases in the presence of a common ion. A common ion is any ion in the solution that is common to the ionic compound being dissolved. The presence of a common ion must be taken into account when determining the solubility of an ionic compound. Estimate the solubility of barium sulfate in a 0.020 m sodium sulfate solution. Write the equation and the equilibrium expression for the dissolving of barium sulfate. Create an ice table wherein X represents the barium sulfate that dissolves in the sodium sulfate solution, expressed in moles per liter. Substitute into the equilibrium expression and solve for X. Since X is going to be very small, the solubility is reduced in the presence of a common ion. The term 0.020 plus X is the same as 0.020. You can also leave X in the term and use the quadratic equation or the method of successive approximations to solve for X. Thanks for watching.